Hello fam, this is our video solutions for Can You Do 42. Before I jump into Can You Do 42, I want to bring up a mistake that I made in Can You Do 41. So if you were in class, you know about this mistake, so you can skip ahead a little bit, but if you weren't or you're one of my virtual learners, I did number 5 backward. I'm sure most of you noticed that as you were watching the video. I thought that the black dots were the males and the red dots were the females, so my response here was backward. The first part was fine, but the second part, I needed to switch it so it said females have a stronger association than males, and females tend to have a lower lean body mass than males, which if I would have been thinking about it carefully, I would have recognized that what I had before didn't make sense, because a lower lean body mass would mean you're fattier, and women tend to carry more fat and men tend to carry more lean body mass. So I apologize for that mistake, and while we're on the topic of me making mistakes, shout out to all the kids who have been helping me realize where my mistakes are at in the notes and in the Can You Do's. Poor Carter had to tell me 3 times that I had a question on the test wrong. So please don't be afraid to tell me if I'm doing something wrong. And as we go through these Can You Do's, just know that if you're getting something different than me and you are pretty sure you're right, most likely you are and I made a mistake. So maybe just check in with me. And usually it doesn't take me 3 times to realize, so usually I realize right when you tell me, but that one test question had me pretty good there for a minute. So, okay, that being said, let's get going on our Can You Do 42. So all of the responses for Can You Do 42 follow the format. I'm going to scooch away for just a second. Okay, I'm back. Sorry to leave you hanging. Follow the format in the back of your notes packet at, letter B. Interpret the correlation coefficient. So this is almost exactly the same as what we did for lesson 41. The biggest difference is that in all of your responses, the form will be linear, because correlation only applies to linear relationships. So on this, you can see that for all of my responses, I highlighted the word linear, just to reinforce that idea. Also, these values are values given from the book. If you are in the same category, then I wouldn't necessarily worry about the value that you estimated. So as long as what you have written here is that you have a strong positive linear relationship or association. I meant to change all of these to association where I have relationship. I apologize. I'm just realizing that. Oh, I did on this last one. So they mean the same thing. I was just trying to be consistent with the words that I use. So relationship is okay here, but I meant to change them all to association. Sorry to get sidetracked. As long as the strength is right, I wouldn't worry so much about how close your R value is. So for this first one, I have a strong positive linear. For B, I have a moderate or moderately strong positive linear relationship. So this is another one that Carter pointed out to me. Carter, I am so sorry. So you can use just the word moderate to describe strength. I didn't realize that until I was going through your book yesterday. Carter had put it in his quiz, and I'm like, well, really, you want to probably say moderately strong, and then I saw it in the book, so my bad, I should give you extra credit for that. You can just use the word moderate here if you would like to. So really, the words are strong, moderate, and weak. I think I lean slightly toward moderately strong, but it's really just your personal preference. So they had this one at 0.5. Without that point, it would probably be a little bit stronger. With or without that point, I would say it's moderately strong. C, they have as weak positive linear. I wouldn't give it as high as 0.3 personally. I honestly think that that's a lot closer to 0, but I do think it's a weak positive linear relationship. And then the last one they have at 0.1, like, to me, these are the same strength. Just because this one has more points, like, for me, they have similar shapes, a similar oval shape, so I think that I would have put that one at positive 0.1. But either way, like I was saying, it would still be described as weak. So this one is the only one that was negative, a weak linear association. So on these, I hope that you're checking all of the other wording too. Like, I hope that you're just pausing and checking real quick that what I have written and what you have written are the same. Just because the AP board is really picky about how you word your answers. Okay, next up. Sorry, my papers are stuck. Okay, matching correlations. So these are my values. My negative with this font is not awesome, so let me darken that up a little bit. So these are my R values that I associated. Rank the correlations. So this one is notoriously one of the more challenging ones from this lesson. So we have 3 situations here. I can screw that top back on when you're done if you want. I'll screw that top back on for you. Oh, perfect. Thank you. Sorry about that, kiddos. So I'm sure that there will be some questions about this. So please, when we're together, if you need a little bit more clarification on this, please don't hesitate to let me know. I was telling you guys in class the other day that I really appreciate how many questions you guys had from the Can You Do. So on this one, if we go through it, whether you're a virtual learner or in class, if you need a little bit more clarification, let me know somehow. So we have 3 situations. We need to rank the correlation between fathers and sons, a female when she's young and when she's older, and then husbands and wives. So in all of these cases, in my mind, it does make sense that there is some correlation. So I personally think, and the book, this is the answer the book has as well, that the largest correlation is the heights of women at age 4 and their heights at age 18. And I personally think that the reason this would have the strongest correlation is because you are talking about or comparing the same person at different ages. So same person means same DNA. So for me, it would make sense that those would be highly correlated. The next one I would say is the heights of fathers and their sons. For a similar reason, I don't think that it would be as strong as the females in the previous example, because that was the same female. You were comparing her height when she was young and when she was old. But in this example, you're comparing father to son. So you don't have the same exact DNA. You have similar DNA, but not the same exact. So I put that one second. So largest correlation is the one that is the same person being compared. The next one I have father-son, and then the smallest one I think is the heights of husbands and their wives. I do think that there is a correlation. I wouldn't be surprised to find out that taller men have taller wives and shorter men have shorter wives, but I don't know how strong that correlation is. I definitely think that it would be weaker than the other 2, where there's some DNA involved. 4, correlation blunders. This is, I think, my favorite question from this Can You Do. I don't know why, I really like this question. I like trying to figure out where things are going wrong. So the following statements, all of them contain an error. Explain what is wrong. So this is the question that made me realize I needed to make it more clear to you guys that when you are calculating R, it has to be between two quantitative variables. So when we did this properties of correlation, I should have added on here that it has to be two quantitative variables. So this one was taking me, the first time I did this problem was taking me like years because I couldn't quite figure out what the issue was until I realized that gender is categorical. So I can't find a correlation between gender and workers because one of them's categorical. I know that there's an association. It's pretty well proven statistically that men make more money than women, but we cannot calculate a correlation for that. We just know that there's an association. B, correlation is a number between -1 and 1. You cannot have a correlation that's bigger than 1, so 1.9 is not even an option. And C, the correlation should not have units. So we don't say 0.23 feet per second, 0.23 miles. You don't put units on it at all. 5, the hot dog problem. The correlation is 0.87. Explain what this value means. So one thing that I wish that I would have talked a little bit more about in class was why the descriptions are so, why we talk about correlation and describing correlation when the descriptions for a scatter plot and R are almost exactly the same. So let me say that one more time. So when we talk about scatter plots, we have two phrases to memorize that are almost exactly the same, and the only difference is the word linear. So what's the point of that? Why have two things that are so similar? And I wish I would have mentioned this in class. The reason why is because we can be given just the R value and know all the things about what the scatter plot looks like or what the characteristics will be. So in the previous lesson, in order to describe the relationship, we had to know or look at the scatter plot. In this lesson, we could have just been given the R value. So they didn't need to give us this picture at all. They could have just said R is 0.87, and we could have still responded with, wherever this data came from, the scatter plot shows a strong positive linear association between calories in a hot dog and salt content of a hot dog. In general, as calories increase, sodium also increases. So that's one of the important reasons why we do both. We learn how to describe a scatter plot, but then we use the same thing to describe correlation because we can just be given R and know all of this without having the scatter plot. Describe one possible issue with using R to describe the scatter plot. So there is no issue with using R to describe it. The issue is that you don't want to use only R to describe this data set. So R is not a complete summary of the data. If we only use R to describe the data, there is no way to know that the data has one outlier, so this guy's an outlier, and two groups or clusters. So there's nothing wrong in using R, but you have to use more than R. What does the outlier, so this guy, have on the correlation coefficient? The hot dog brand with the lowest sodium content is an outlier in the pattern of linearity. It's in the pattern, so it will strengthen the correlation between the variables. Okay, this is strong association but no correlation. Use a calculator to help sketch a scatter plot to examine the researcher's belief. I'm not sure that you needed to use your calculator, but to plot it at least. So it looks like a negative parabola. Use your calculator to find R. R is 0. In fact, I thought that I had never seen a data set that had an R of 0, but then I did this can you do yesterday, and I remembered that there is this example. Explain why the correlation has the value found in part B, even though there is a strong relationship. The correlation is 0 because the relationship is nonlinear. You can only use R to describe linear relationships. So it's 0, even though there clearly is an association between speed and miles per hour. The R is 0 because it's nonlinear. The relationship is that your gas mileage, it gets better as you move up to 40 miles an hour, and then it gets worse once you are, I'm saying that backward. I'm glad that I caught that before I released this into the world. So let me say that again. Up here is where you want to be. So did I have it backward? The mileage of an automobile first increases and then decreases as speed increases. So does mileage mean miles per gallon? Because if that's the case, yes it does. I don't understand why this is the way that it is. Because typically, as you drive faster, your car gets better gas mileage because you're on the freeway. Have any of your parents ever talked to you about how freeway miles, you get more freeway miles than road miles? So I think this needed to be this way. No, I'm not sure how it needed to be, but I don't think that this is the true relationship is what I'm saying. Because for sure, you get worse gas mileage in the city than you do on a highway, because in the city, it's all stop and go, and that takes your car more gas than if you're on the freeway and doing the speed limit and have no stop and goes. If you're speeding, then you don't get good gas mileage. And that's not just me trying to get you not to speed. That's truthiness. So anyways, I'm sorry. I hope you guys fast forward through all this stuff if you don't care. These answers are correct, but I am not sure that this is the true relationship between road miles and highway miles. Or I guess I should say speed as speed increases. So, I don't know. But I know this is right. Sorry about all that. Sorry if I confused you. 7 is A as in apple. 8 is E as in echo. And this is true for a lot of things that you guys buy. For almost everything, I can't think of a single thing that as the price it takes to manufacture something increases, the sales price does not also increase. Typically, the price is based off of the manufacturing price. So if the cost that it takes to make it increases, then that means they're going to have to sell it for more to make their profit. So echo is the right one there. 9 is delta. Delta. I think C, I think some of you guys may have chosen C. The other one should have obviously been wrong to you. A, B, and E should have been wrong. C, I can see how you would consider that, but this says there is little difference between Japanese cars and cars made in other countries. Really, there is a noticeable difference. Like, after the Japanese cars weigh less than almost half of the cars in this scatter plot. So it's clear to see that Japanese cars are lighter than a lot of cars. 10, I had to plot data for this. In fact, I printed this, and I bet you I don't have, oh, good, I did. So I had to, there was a couple things that I wanted to talk to you about. I'll talk to you about one of them at the end. I had to actually write down some heights and for men and women. So this was my women, this was my men. I plugged it into my calculator and I got a correlation of 1. Because if it's 2 inches higher every single time, then that means the slope of your line would be 1, I believe. Maybe this is not slope, but it's for sure 1. It's a perfect linear. Oh, so the slope is not 1. The slope is not 1, family. It's a perfect linear relationship. So 1 means that the relationship is perfectly linear. So it doesn't have to do with slope of the line. It just means perfectly linear. The dots would all be in a straight line. And I plugged it in and graphed it, and they were in a straight line, and my calculator correlated it, or got an R of 1. Next up, 11 is beta. It's outside of the pattern. This next one was really hard for me. If we leave out the low outlier, the correlation would be closest to. I think if you leave out that outlier, that relationship would be stronger than 0.5, because you can use a line to describe the relationship. I think that's a little bit too low. And then you could like draw the oval. And I just don't think that that's I don't think that that's a 0.95 oval. I would not categorize that as strong. Like 0.95 is very close to a line. So I chose this, even though this oval is moderate. This oval would definitely be categorized as moderate. I chose the lower one because I don't think that that is close to 0.95, was my reasoning. I might need to check this one. If you guys are worried about that one, ask me in class. And if you're a virtual learner, just send me a quick email. I'll double check the book on that one, but I'm pretty sure it's 0.5. The tennis ball thrown into the air is beta. There is not a linear relationship between time and height. It has the miles per gallon relationship. So if you graphed the data for the distance the ball travels, it would look like this. You throw the ball up, and then it comes back down to where you threw it from. So there is no linear relationship, but there is one. Okay, the last thing that I wanted to tell you, which is something I should have told you at the very beginning, and that has to do with the limb problem. I struggled with the limb problem because at first when I looked at it, I thought that it was negative. So when I looked at the limb problem, I was seeing this. I wasn't seeing the positive correlation. So I had to blow up the limb problem, and I had to try to figure out for myself how they ended up getting a positive correlation. So I had to really think hard about, well, what's happening to my points as I move right? So if I really went slow and thought about, okay, as I move right, what is happening to my points? They're going up. They're going up. They don't start going down until you get to like 30. So I only saw the down portion, but really it doesn't start doing that until after 30. So it really is going up, and most of the points are increasing, and then you have these weird points out here that are doing their own thing. So if the limb problem was challenging for you, this is just me telling you it was challenging for me too. And I had to really go through and slowly look at what's happening to Y as X is getting bigger. So that's how I was able to figure out, well, why are they saying this is positive and not negative? Okay, that's that. I apologize. This video is probably 5 to 7 minutes longer than it needed to be because of all the things that I tell you that I don't know that are really necessary to the Can You Do. So I think at this point, though, most of you have learned to just fast forward if it's stuff that you don't need. Yeah, I will check that one multiple choice problem. If you're worried about it, just ask me and I'll let you know. And I think that's it. Love you guys. Hope you're having a good one.